Okay, 2019 relative velocity, question 2b. A rescue boat whose maximum speed is 24 kilometers an hour is 18 kilometers southwest of a fixed point. Let's just draw that real quick. 18 kilometers. We'll call this point B for the boat from a fixed point P. There's a constant current of 4 kilometers an hour flowing uniformly in a direction south 30 degrees east. Well, let's just set up that's east. So south 30 degrees east. This is south, so it's going down this way. This is the current. And my 30-degree angle would be in here. So that's the current flowing south 30 degrees east. The rescue boat sets out to get to P as quickly as possible. Find the time to the nearest minute to reach P. Okay, southwest from P would mean that this angle is 45. And this, the 30 and this angle here are 90 degrees. So that will be a 60. So I could create a triangle by going down here and saying that this is the velocity of the boat relative to the current. And if we take that information out and draw another triangle just to give us some room, the velocity of the boat relative to the current, well, its max speed is 24. The velocity of the current is 4. We have this angle 60 plus 45 is 105, so we could create a triangle and use the sine rule to get whatever we want within this triangle. So we want to get the time, we need the velocity of the boat going up in that direction to get to P. The velocity of the current is coming down this way, and the velocity of the boat relative to the current that way. Okay, well, let's get our angles. What have we got? We have sine 105 over 24 is equal to 4 over the sine of this angle up the top here, which we'll call A. So 4 by 24 is 90. No, sorry. What have I done? Upside down. Sine is on top on the left, so keep it on sine of A on top over 4. So 4 sine 105 is equal to 24 sine A. So bring that 24 underneath and get the inverse sine of 4 sine 105 over 24. And we type that into a calculator. We get 9.3 degrees. Okay, I think this is opposite the velocity of the boat, so we're going to need this one here. That's going to be 180 minus 105 minus 9.3, which is equal to, what's that, 65.7 degrees. Okay, where to next? So now that we have all our angles, we have the angle opposite the velocity of the boat. So we do another little sketch of a triangle. We can use, oh, that is a terrible line. We have the velocity of the boat. We have this angle here, 65.7. Now we could use either of the other ones, 105 here and 24. And a 4 here and a 9.3. So we could use sine rule. We can use either one of the angles. So sine 105 over 24 is equal to the sine of 65.7 over the velocity of the boat. So 24 sine 65.7 divided by sine 105 is equal to the velocity of the boat. And if you type that into your calculator, you are going to get 22.65. Now, that's not what we're asked. We're asked the time it takes for the boat to get there. So we have the velocity. So the time, what's the distance again? It was 18. So the time is equal to distance over speed. So it's going to take 48 minutes. Just multiply that by 60 just to show the math involved. By 60, change that decimal into minutes, and that works out to the nearest minute, 48 minutes. Now, the second part of this question. We're told that a yacht is in distress near P and it sends a signal to the rescue boat. When the boat arrives at P, the yacht is 6 kilometers north of P and is drifting with the current. The rescue boat sets out from P to reach the yacht as quickly as possible. Find the time taken by the rescue boat to reach the yacht. Well, that's straightforward enough. Here's the boat gets to P. The yacht is here. It's 6 kilometers away. Now, the current is going to affect the boat. It's going to, what was it, drifting this way? But it's also going to affect the yacht that it's going to rescue. So the current affects both the same. So the speed of the boat, it can travel at 24. The distance it needs to travel is 6. And 6 divided by 24 is a quarter of an hour, which we know is 15 minutes. So get practicing on 2019 relative velocity.